All right, this is G Glizzy coming at you with another video. So we're going to go over projectile motion review in this. So we're going to start on number 1. So a stone is thrown horizontally at 5 meters per second from the top of a 78.4 meter high cliff. So this is type 1 projectile. So remember, type 1 is when you have something that's going off of an object. It's basically rolling off, falling off. That's type 1. And type 2 is where we actually launch something with an angle. Okay, and we're giving you a value. Okay, so we're giving you a hypotenuse. Okay, so that's the difference between type 1 and type 2. So there's certain things you need to do for type 1 versus type 2. So on type 1, it's been a second since we've looked at this stuff. So we're going to go ahead and just draw our little cliff here. So we don't really care about grading your drawing, but sometimes it helps to kind of label things. So it's thrown horizontally at 5 meters per second, so it's being launched off at 5 meters per second. Okay, and a 78.4 meter high cliff, so 78.4. So on a type 1 problem, what I always do is always set up a T-chart. Okay, so I like to set up my horizontal side and my vertical side, so just be careful on where you put things, because usually that's where we see the most common mistakes is not putting it on the right side. So on the horizontal side, remember it's always Vx, Dx, and T. And then on the vertical side, it's going to be your Daffy T. Okay, so Vx, so it says the stone is thrown horizontally at 5 meters per second, so that's a dead giveaway that Vx is going to be 5. Okay, and it says it's 78.4 meter high cliff, so that means it's falling, so that's vertical distance. So now I'm going to make that negative 78.4 because that's just going to help with your signs later on. And technically, since you're falling, that's why it's negative, because you're falling from your original position. So it says, how long does it take to reach the ground? So that means we're looking for time. So time is on both sides. Time is the only thing that's universal. So there's a couple things I can fill in, though, that I should know is A is always going to be negative 9.8 because that's gravity. And on a type 1 problem, your initial velocity is 0 because you were sitting on a cliff and then you weren't. Okay, so you weren't moving and then you started falling, so you had to start at 0. Okay, so I don't have enough on the left side to find time. I would need dx in order to do that. So I'm going to use my Daffy T side to find time. So I'm going to cross off VF. So that means we're going to use equation number 3, which is the D equals VIT plus 1/2 AT squared. Okay, so since VI is 0, this whole thing goes away. Okay, so please do not keep that T because 0 times T is going to be 0. So now we can plug in, so negative 78.4 equals 1/2 negative 9.8 times T squared. So what I would do is I would divide both sides by 1/2 times negative 9.8, which is negative 4.9. So divide both sides by that, and you're going to get 16 equals T squared. Now, do not forget that square. I've seen a lot of students, they just miraculously, that square just disappears in that step. So don't forget that squared because I have to square root both sides to get rid of it. So that means it actually takes 4 seconds for that stone to hit the ground. Okay, so there's your answer for part A. B, how far from the base of the cliff does it land? So that means it's wanting to know this. How far does it go horizontally? So remember, Vx, Dx, and T. So Vx we already know is 5. Dx is your question mark. And we just found time, which is 4 seconds. So remember, Vx equals Dx over T. So we're going to do 5 equals Dx over 4. So I'm going to multiply both sides by 4. And I'm going to get a horizontal distance of 20 meters. So that's how far it lands from the cliff. All right, C, this is probably the number 1 missed question as far as calculating goes on a type 1, okay, because it's got a few steps to it. Resultant velocity, that just basically means hypotenuse and angle. It means what is the resulting velocity when you mix horizontal and vertical velocity, because when you have something falling, it's not just dropping, it's falling at a diagonal, okay, which means it's made up of a horizontal plane and a vertical plane. So resultant is that X, which is the diagonal, and your angle. Now, good news is we already know that our horizontal velocity is 5. That's never going to change. Okay, but we don't know this. Now, the number 1 mistake I'm seeing is I see students, I'm going to mark it in red, is they see this height right here, and they try to plug in this 78.4 right here. If I'm talking about velocity right here, that is not a velocity. That's a height. That's meters. So you cannot mix 5 meters per second and 78.4 meters because they're not the same thing. So be careful with that. So what we're going to do is we're going to find our VF at that time, okay, because I told you at 2.75 seconds. So if I want to find anything vertical, remember you always set up DAFI-T. So VI is going to be 0, A is negative 9.8, T is now 2.75, VF is what we're looking for. That means D does not matter. So we're going to use equation number 1, which is VF equals VI plus AT. So we're going to plug in. So VF equals 0 plus A, which is negative 9.8 times 2.75. Okay, and you're going to get a final velocity of negative 26.95 meters per second. You can put it as positive if you want to. It honestly doesn't matter. Okay, it's just negative because it's falling. Okay, so that is not our answer, but that is the velocity that we can now plug in right here. Okay, so if I know two sides of a triangle, I should be able to find my hypotenuse and my angle. So if I want to find my hypotenuse, we're going to do the whole a squared plus b squared thing. So we're going to take the square root of a squared plus b squared, so 5 squared plus negative 26.95 squared. Sorry, I'm running out of room. So take the square root of both those squares and you get a resultant velocity of 27.41 meters per second. Now that is your magnitude. We don't know our direction yet. So we're going to find our angle. So remember, inverse tangent of opposite over adjacent. So opposite is that 26.95, and you can leave it as negative if you want to. You're just going to get a negative angle. Either one's fine. Okay, over your adjacent, which is 5. So make sure you're in degree mode when you do this, and you should get an angle of 79.49 degrees, and your direction is going to be below the horizontal. Okay, that's always going to be the direction because you're just falling. Okay, so there is my angle, there's my direction, and then my magnitude. Now, if you drew your triangle the other way, so like your triangle looks like this, where you went down first and then over, okay, that's fine. You'd still get the same hypotenuse. Your angle would be different. Okay, your angle would be like 11.51 degrees because our angle should add up to 90. Okay, so either one's fine. Doesn't matter how you draw that one. So there's your answer. D, what is the resultant velocity of the stone just before it hits the ground? So resultant again. So we're going to do the same thing, but now I want to know what is it when it hits the ground. So that means I'm no longer dealing with that 2.5 seconds. So I'm going to draw this out again. Okay, horizontal is still 5. That didn't change, but this has changed now. Okay, whatever we solved for in part C is come and gone. Okay, so vertical velocity is always changing. So I'm going to do DAFI-T again. Okay, A is negative 9.8. VF is your question mark. VI is 0. Okay, now we already solved for our time up here in part A, 4 seconds. So now we're going to plug in 4 seconds there. And we're still going to use the same equation of VF equals VI plus AT. So VF equals 0 plus negative 9.8 times time, which is 4. So VF is going to come out to be 39.2 meters per second. Or you can leave it as negative. Honestly, doesn't matter. So now I'm going to do is I'm going to plug that in. So I'm going to do find my x and my angle. So x equals the square root of 5 squared plus 39.2 squared. Okay, I'm going to square root all that, and you should get a resultant value of 39.52 meters per second. Okay, so there is your magnitude. So we're going to find our angle. So we're going to do inverse tangent of opposite, which is 39.52, over adjacent, which is 5. And you're going to get an angle of 82.73 degrees below the horizontal. So there you go. So if you drew your triangle the other way, okay, you should get 7.27 degrees. Okay, as yours, that's fine. Either one works. So that is basically how you do resultant. It's the same steps every single time. You just got to be careful on what you're using. Now, we're going to go to number 2. It says a kicker kicks a football at the velocity of 27 meters per second at an angle of 30 degrees. So this is type 2. Okay, so type 2, remember, it has a launch angle, so 30 degrees. And that 27 meters per second is your hypotenuse. Determine the time the ball is in the air, okay, the range, and the ball's maximum height. So remember on these, I always do the same thing every single time. I'm going to find my Vx, find my Vyi. So remember Vx is going to be 27 times cosine of 30, okay? Because remember, cosine helps you find your adjacent, and Vx is the adjacent. So 27 times cosine of 30, and you're going to get a value of 23.38 meters per second. Okay, Vyi, we're going to do the same thing, but we're going to use sine instead because it helps us find our opposite. And you're going to get a value of 13.5 meters per second. Okay, so neither one of those are my answer to part A, but I'm going to need those. Go A, it says the time the ball is in the air. Okay, so remember I give you this equation. T total, or on your equation sheet, it says T hang. That means just hang time. Okay, it's Vyi divided by 4.9. So what you're going to do is take that 13.5 that we just found and divide it by 4.9, and you're going to get 2.76 seconds. Now, that is the total time. Okay, so that is from launch, goes all the way up, comes all the way down. Okay, that is the total hang time. If I asked you how long does it take to get to the top, all you got to do is just split that time in two. Okay, so B, the range. So range is horizontal distance, so make sure you know that term. So remember Vx, dx, and t, that never changes. So Vx is 23.38. Okay, and just in case you need this again, remember when we split that hypotenuse up, we will never use that 27 again. Okay, so you will only use Vx and Vyi. Okay, so don't use that 27 on either A or B. Okay, dx is what we're looking for, and time, we just found it was 2.76. Okay, so Vx equals dx over t, so 23.38 equals dx over 2.76. So multiply both sides by 2.76, and you're going to get a horizontal distance of 64.53 meters. And that's it. Okay, C, it says the ball's maximum height. Okay, so that means we're looking for vertical. Remember, anything vertical, we're always going to set up Daffy T. Okay, so A is still negative 9.8. Okay, height is what we're looking for. That is your distance. Now, this is where you got to be careful. We're switching to a type 2 problem. When you launch something up in the air, it keeps going and going and going and going and going until it stops at some point. So your VF is now 0. In a type 1, your VI was 0. But in type 2, your VF is 0 because you're launching it up. If you put 0 for VI, that means it never wouldn't have even have left the ground anyway. So there has to be VI, which we already found that. It's the VYI of 13.5 meters per second. Now, again, I've talked about this in other videos and in class. Could you use time? You could. Okay, but what happens is a lot of people try to use that whole time, that 2.76 seconds, when technically you need to split it in half before you do that calculation. So I usually don't do that because I don't want to mess up that step. So I'm just going to use the VYI I've got and just leave time out. So that gives me the equation of VF squared equals VI squared plus 2AD. Okay, so I'm going to plug in. So 0 equals 13.5 squared plus 2 times negative 9.8 times D. So I'm going to do is I'm going to move that 13.5 squared over to the left side, and it becomes negative. So 182.25 equals negative 19.6 D. So divide both sides by negative 19.6, and you're going to get a height of 9.30 meters. That's it. D, assuming the same initial speed, what other angle projectile would have the same range? Okay, if you want them to land in the same spot, they have to add to 90. Our angle that we have here is 30 degrees. So 30 plus blank gives me 90 degrees. So that means if I had launched it at 60 degrees, it would land in the same spot. So it would kind of look like this. 30 would be lower. It wouldn't have very much hang time. Okay, 60 is going to have a lot more hang time, so it's going to be in the air longer. Okay, but they're going to land in the same spot. So as long as they add to 90 degrees, okay, they will land in the same spot. Next problem, a soccer ball is kicked horizontally from the roof of a building and falls to the street 40 meters away from the building. So we're back to a type 1. Okay, so let me redraw that. Okay, so if a soccer ball, it's kicked horizontally. Okay, it lands 40 meters away from the building, so that 40 meters is my horizontal distance. It takes 4.8 seconds to hit the ground. So I'm going to do is I'm going to go ahead and set up my t-chart. So x, y, so vx, dx, and t, and then Daffy t over here. Okay, so 40 meters away from the building, that has a horizontal distance, so I'm going to put that on my horizontal side, so please be careful on where you put things. Do not put that on the vertical side. Okay, and I gave you time, 4.8 seconds. Time can go on both sides. I'm going to go ahead and plug it on both sides. Okay, time is the only thing that can go back and forth. We know VI is 0, and then A is negative 9.8. And it says, what is the height of the building? So that means I am looking for vertical distance. So I'm going to leave off VF. So I'm going to use that third equation, okay, which is the D equals VIT plus 1/2 AT squared. Remember, VI is 0, so this whole thing goes away. So D equals 1/2 negative 9.8 times 4.8 squared. Okay, so do that math, and you should get 112.90 meters, and that would be it. Okay, B, what is the horizontal velocity? That means you're looking for Vx. You already know dx. We found that it's 40. Okay, you know your time is 4.8. So Vx equals dx over t, so 40 over 4.8. And you get a horizontal velocity of 8.33 meters per second. Part C, what is the vertical acceleration at 2 seconds? So this is kind of a trick question. Okay, what do we always know the acceleration to be vertically? Okay, so remember, your vertical acceleration, or AY you can call in this case, is always going to be negative 9.8 meters per second squared. Okay, if I ever asked you about horizontal acceleration, so AX, that would be 0, because remember, horizontal velocity doesn't change. So if your velocity is constant, that means you're not accelerating or decelerating. So you have an acceleration of 0. So your answer would be this, negative 9.8 meters per second squared. So it doesn't even matter the time. Okay, at 1 second, 2 second, 3 second, it's always going to be negative 9.8. All right, number 5, a golf ball is driven at 60 meters per second from level ground. What is the maximum range of the golf ball? Okay, so maximum range right there just told me a couple things. 1, I'm looking for the horizontal distance. And 2 is, if you notice, we know this is a type 2, that we had to launch this up off the ground. Okay, but I didn't give you an angle. I gave you the hypotenuse, but I didn't give you an angle. But when I say maximum range, that's a hint that what is the best angle. And we've talked about that before, is that 45 degrees is the best angle for distance. Okay, so if you see maximum range and I don't give you an angle, that's a hint that you should be using 45 degrees. So I'm going to go ahead and break into Vx and Vyi. Okay, so I'm going to go ahead and do that. So Vx equals 60 times cosine of 45. Okay, and again, if you're not getting the same answers as me, make sure you're in degree mode. So you get 42.43 meters per second. And we're going to do Vyi. And we're going to do 60 times sine of 45. And it is okay to get the exact same answer because remember, 45 degrees is right in the middle. So that means vertical and horizontal are even. Okay, so you're not more vertical and you're not more horizontal. Now, I'm going to go ahead and find T total, our time. Okay, I always do these 3 things every single time. So 1, 2, 3. So that's Vyi divided by 4.9. So 42.43 divided by 4.9. Okay, and you're going to get a time of 8.66 seconds. Oops, 66 seconds. Now, I'm asking for range now, so we're looking for dx. So we're going to do Vx equals dx over t. So Vx we already know is 42.43. Dx we don't know. And we just found time, 8.66. So multiply both sides, and you're going to get a range of 367.44 meters. B, what is the maximum height the ball reaches? Okay, so sorry I forgot to box that. That's your answer. Okay, height is going to be Daffy T. So that is your question mark. A is still negative 9.8. Remember, VF has become 0 now. VI, I found that was 42.43. And we're going to leave off time. So VF squared equals VI squared plus 2AD. So 0 equals 42.43 squared plus 2 times negative 9.8 times distance. So multiply. So I'm going to go ahead and square the 42.43, and then I'm going to bring it over to the other side. That gives you negative 1800.43. I'm sorry, 30. Negative 1800.30 equals negative 19.6 d. So divide both sides by negative 19.6, and you should get a height of 91.85 meters. See, how long does it take to reach the maximum height? Okay, so that means you're looking for time. And well, we already know total time. Okay, so our total time was 8.66 seconds. So that is from launch to when it comes back down to the ground. Now, if I want to know the time it takes to get to the top, all you got to do is just half that. So divide by 2, and you get 4.33 seconds. If the hole is 400 meters away, where does it land relative to the hole? Well, we know it landed 367.44 meters away, so I'm going to do is 400 minus 367.44 meters. That means it landed 32.56 meters. We'll just say in front. All right, now the conceptual stuff. So this is important because a lot of people are missing the conceptual stuff. So we're going to talk about horizontal and vertical, all that kind of stuff. So a projectile does not have horizontal velocity. Well, that's going to be false. Otherwise, it would just be sitting still, or it's just going straight up in the air. Okay, so which we haven't talked about that. So we've been talking about things going off a cliff. We've been talking about launching things. Now, could a projectile be something that is launched straight up in the air? Then yes, it wouldn't have a horizontal velocity, but we haven't talked about that at all. Okay, we've just been talking about either going off a cliff or some type of surface and then launching something up in the air. So for everything that we've discussed, you always have a horizontal velocity, and it's not changing. Okay, so it does have a horizontal velocity. The horizontal velocity of a projectile changes by 9.8 meters per second each second. That is the effect of gravity. Okay, gravity affects vertical. It does not affect horizontal. That's why horizontal doesn't change. So this would be false. C, the horizontal velocity of a projectile is 0 meters per second at the peak of its trajectory. That means if I launch something like this, and if you say that's true, that means it just stops dead in its tracks right here and just drops. That is not going to happen. Okay, so horizontal velocity stays the same the entire time. Now, vertical velocity will turn to 0, okay, but in this case, horizontal velocity will stay the same and it will not be 0. D, the horizontal velocity of a projectile is unaffected by the vertical velocity. These two components of the motion are independent of each other. This is true. They are perpendicular. That means they do not affect each other at all. So whatever one does, it doesn't affect the other one at all. E, the final horizontal velocity of a projectile is equal to the initial horizontal velocity. That's true because we said it never changes, so it should be the same at the beginning and the end. F, as a projectile rises towards the peak of its trajectory, the horizontal velocity will decrease. As it falls from the peak of its trajectory, the horizontal velocity will decrease. Well, one, this is all wrong because we just said horizontal velocity does not change. So this is definitely false. Okay, so there's none of that's true. So nothing changes at all. Vertical motion. The vertical component of a projectile's velocity is a constant value of 9.8 meters per second. If you said that's true, that means if you launch something up at 9.8 meters per second, it's going to keep going until it hits space and just keep going and going and going. Okay, so this is going to be false because you got to be careful with this. This 9.8 is kind of trying to lure you out there. Okay, 9.8 meters per second squared would stay constant, but that's acceleration. Okay, we're talking about velocity here. So velocity is slowing down as you go up and then speeding up as you come down. Okay, so it's not going to stay constant. B, the vertical component of a projectile's velocity is constant. We just talked about that in part A. It's always changing. Okay, so it's never going to stay the same. C, the vertical component of a projectile's velocity is changing at a constant rate. That is true. That is the effect of gravity. Okay, so you are changing by 9.8 meters per second every second. D, the vertical velocity of a projectile is 0 at the peak. Okay, that is true. Okay, that means you stop at the top and then you come back down. The vertical velocity of a projectile is unaffected by the horizontal velocity. These two components are independent of each other. That is true because they are perpendicular. The final vertical velocity of a type 2 projectile is always equal to the initial vertical velocity, but in the opposite direction. That is actually true. That means if I launch something up at 5 meters per second, okay, whenever it comes back down, when it hits the same spot I launched it from, it's going to be the same velocity, but just negative. So it'll be negative 5 meters per second. G, the vertical acceleration projectile is 0 meters per second when it's at the peak. Okay, so vertical acceleration does not change. It's always negative 9.8. If that goes to 0, that means gravity's gone, and at that point we have much bigger problems to worry about than your physics test. Okay, so acceleration is not going to go to 0. Your velocity can go to 0, but acceleration is not going to. Okay. Let's see. A projectile rises towards the peak of its trajectory. The vertical velocity will decrease. So far that's right. As you go up, you slow down. As it falls from the peak of its trajectory, the vertical velocity will decrease. All right, that's false. So that means it has to increase as you go down. Okay, so that's going to be false. All right, hang time. The time of the flight or total time in the air. The time that a projectile is in the air is dependent upon the horizontal component of the initial velocity. All right, remember we give you this equation. T equals VYI divided by 4.9. Okay, at no point in that equation does Vx even come into play. Okay, so horizontal does not affect your time. B, and a good question on that is, that's like when we talked about if you were to fire a bullet horizontally versus drop the bullet at the same time, which would hit the ground first? Both of them. So it had nothing to do with the bullet being fired versus being dropped. It was just the height from where it's falling. So it's strictly vertical. B, the time that a projectile is in the air is dependent upon the vertical component of the initial velocity. That is true. For a projectile which lands at the same height that it is projected from, the time to rise to the peak is equal to the time to fall from the peak of its original height. All that means is if you launched it from a surface, so let's just say this is our surface, we launch it from here, and then it comes back down. We're just saying that the time it takes to get to the top is equal to the time it takes to get back to the bottom, which is true. Okay, that's just half of your hang time. For the same upward launch angles, projectiles will stay in the air longer if the initial velocity is increased. Okay, so if that means if I have something launched at, we'll just say 30 degrees, and I launch something at 5 meters per second, okay, it's going to go a certain height. Okay, if I take that same thing, but now I make it 10 meters per second, that thing should go a lot higher, which means it will affect my hang time even more. So if you do increase that velocity, yes, your hang time will increase. Okay, assume that a kickball in football is a projectile. If the ball takes 3 seconds to rise to the peak, it will take 6 seconds to fall from the peak back to the ground. What we just talked about is whatever time it takes to go up should be the exact same time it takes to go down, so that would be false because that should be 3. All right, and that'll end that one.